come back to the next example in the study of calculus. So let's solve this problem here involved in the study of limits. So I have the limit as x tends to infinity. So please, this symbol is refers to as infinity. And the crazy thing here is that this infinity can be given in terms of minus infinity. Some cases you might not see just infinity, you might see plus infinity. Sometimes you might see minus infinity, or perhaps infinity as this case. Whichever one you see, please follow the same procedure I will show you now. So in a case like this, when you have infinity as your um, x tends to or approaches to concept, your task is simple, right? For infinity I there, the first thing that should come to your mind is dividing through by the highest power of the variable. If you check this properly here, my variable, by variable, I mean alphabet. What I'm saying here is x. So which x has the, in quote, the highest power? Obviously, x cubed is the highest power here. X cubed is the highest power. So I'll divide everything by the highest power. Sorry, by the variable with the highest power. So divide through. So I'll divide through by the highest power. Of course, here it was x cubed is the highest power of the variable. This is how you solve anything involved infinity. Your first priority, check the variable with the highest index, right? So in this case, this gives you the limit as x tends to infinity. This man gives you 5x cubed over divide through. That gives you x cubed. I have minus, this one gives you 4x squared over x cubed. Moving on, this one gives you 2 over x cubed. That's numerator. All over, this one here gives you 10x cubed over x cubed. So divide through, right, 1 by 1. Minus, this one gives you x squared over x cubed plus, this one gives you 3 over s cubed. I said when it comes to infinity, please don't stress. Just check for the variable with the highest index. Whichever one is the variable with the highest index there, divide all the expressions by that highest in variable index, right? As you can see in this case. My next priority is to now apply my basic mathematics knowledge. I know that this one here will cancel this. X squared will cancel x cubed. I'll have 1x left here. This one will remain the same. Obviously, from this one cancels this one. X will cancel x cubed. I have 1x left here. So in other words, I'll have the limit as x tends to or approaches to infinity. This man will give you what I have left here, just 5. So that gives you 5 minus, of course, this gives you 4 over x. I have 4 over x, then minus 2 over x cubed. That's 2 over x cubed. All right, all over. So it gives you 10. That gives you 10 minus x squared is gone. That gives you 1 over x. I have 1 over x. Then plus, I have plus, this one gives you 3 over x cubed. I have 3 over x cubed. Please, at this junction, don't forget that whenever you have a number, let's say 100, all over infinity, please, your answer is 0. Please notice, please. Any number over infinity gives you 0. I'm saying again, please. Any number over infinity gives you 0. 1 billion over infinity gives you 0. 3 quadrillion over infinity gives you 0. 2 over infinity gives you 0. That is to say, the limit, observe this please, the limit as x tends toward the infinity becomes 5 minus 4 over anywhere I see x, I'll put infinity. That gives you infinity minus 2 over infinity cube all over. This one gives you 10 minus 1 over infinity plus 3 over infinity cube. Please, I said earlier, any number over infinity, that stuff gives you 0. It means that I'll have 5, observe please, 5 minus 4 over infinity gives you 0, minus 2 over infinity cube gives you 0, all over, I have 10 minus 1 over infinity gives you 0, plus 3 over infinity gives you, of course, cube gives you 0. What I have left, obviously, is just 5 over 10. So I have 5 over 10 left. 5 here, 1. 5 here is 2. My final answer here becomes 1 over 2. So this is how you evaluate problem when it comes to infinity concept. So this is how you solve problem involved in the study of infinity, as you can see on the board. All right, this another past questions. So let's take yet another past question. The study of calculus. Okay, welcome back. Let's solve this problem also involved in limit. So my very first priority here is to check this properly. I said in our previous class, right, when we learned limits from scratch, I'll leave the link to learn limits from scratch in the video description. So check there. You see a link, a playlist of ours where I teach you limit from scratch. So go and watch those videos there, right, to enhance the better understanding of this concept. I said when it comes to limits and you are having root either up or down, whichever way it appears, what comes to mind? Rationalization. Please, in our previous example, I said whenever you have limits, so infinity as your x, what comes to mind there? Divide by the highest power. In a case like this, when you have root, either up or down, whichever way there, what comes to mind there? You have to what? Rationalize. So at this junction here, I will rationalize. From the idea of sort, when it comes to rationalizing, we have to understand what we call conjugate, right? So what's a conjugate? By conjugate, my first task is to get the conjugate of that term I want to rationalize. So we are rationalizing the term with the root. So I have to find the conjugate of this one here. So the conjugate of root 9 plus x minus 3 becomes root 9 plus x plus 3. Obviously, when it comes to conjugate concept, the sign changes. So here was minus. The conjugate of this becomes what? The plus. If I have 5 plus q, what the conjugate? That gives you 5 minus q. So the idea behind conjugate is just changing the sign from the initial one to the what there to the opposite one. That's like the idea of conjugate. So here's the task, please. When it comes to rationalizing, I'll multiply numerator and denominator by the conjugate of numerator. I said multiply numerator and denominator by the conjugate of the part that has root, which of course what? Numerator. So I'm saying is that the limit as x tends to 0, and by the way, if I put x as 0 here, everything becomes 0, right? So I have to show myself. So this one gives you x tends to 0. I have so multiply, this gives you square root of what? 9 plus x, then minus 3. So multiply this by this conjugate into root 9 plus x, then plus 3, all over this denominator, which is x, still multiply by what? The conjugate. That gives you 9 plus x root 9 plus x plus 3. This is how you evaluate rationalization here. So I have this here. All right, I have this. Now I'm going to expand this numerator, leaving denominator pending, right? So how do you expand two brackets? I said when it comes to expanding two brackets from the idea of binomial theorem, we said you have to pick out the first term. So I said you have to pick out the first term in the first bracket here, multiply by everything in that bracket. That's case 1. Case 2, bring a second term, which is minus 3, multiply by everything in the other bracket. That's all. So it means that I'll have root 9 plus x, right? Multiply this by everything, and that gives you root 9 plus x, then plus 3. I have this done. My first task done. Next up, minus 3, I have minus 3. Multiply by everything, and that gives you root 9 plus x. Of course, I have plus 3. That's my numerator. All over, this one gives you x into, I have root 9 plus x. Of course, plus 3. It becomes my expression here. All right, at this junction here, I'll multiply. Please don't forget from the idea of sort. If I have root a multiplying root a, my answer is a. I'm saying if I have root of something, multiplying root of that same stuff there, my answer becomes that stuff. So I'm saying is if I have root 9 plus x, multiplying root 9 plus x, my answer becomes what there? 9 plus x. That's that. I have plus sign, that's plus. 3 times root 9 plus x, that gives you 3 root 9 plus x. This stuff here is minus. I have minus 3 times root 9 plus x, that gives you 3 root 9 plus x. Plus minus gives you minus. 3 times 3 gives you 9. Numerator is done. All over, I said keep denominator pending. That gives you x into root 9 plus x, of course, plus 3. I have this expression here. If you observe properly, this stuff here plus 3 root x will cancel minus 3 root x. Yeah. So I'll have what I have left here. If I should proceed further, I'll have 9 plus x, then minus 9 all over I have x into root 9 plus x, then plus 3. All right, I have this. Obviously, if you observe here, plus 9 and minus 9 gives you 0. So plus 9 will cancel minus 9. Thereby, I'll have what left? I have s all over x into the square root of root of 9 plus x, of course, plus 3. All right, I have this. All right, so at this junction here, this x here will cancel this x, leaving me with 1 all over root 9 plus x, then plus 3. Right, so it took me experience to know that I don't have to expand this. So here's the tax here. If you're rationalizing numerator, if numerator is what you're having as a square root, that is what you keep um, evaluating, right? You keep solving. But that down part does not have root. Just let it remain the same. Let it remain the same, right? At the end of the day, something down here will count something up here. But if you're expanding numerator, at the same time, denominator, you have issue. So from experience, I'm saying this: the part that has root is what you will keep evaluating. Like this one here, I solve this numerator, I still solve numerator, I keep this man does not have root pending, right? You can see at the end of the day, something cancels each other. So that's like the key take from this concept, right? So what I'm having left here, 1 over root 9 plus x plus 3. What's the limit? Limit as s tends to 0, right? So put s as 0. So put x as 0. This one gives you 1 all over root 9 plus 0, x is 0, then of course plus 3. This one gives you 1 all over root 9. 9 plus 0 gives you 9. What's root 9? That's 3 plus this 3. My answer becomes 1 over 6. This is how you solve problem under a square root of limit, right? So in case you have a square root under limit, what comes to mind there? You have to rationalize. This is how you work with this kind of problem. Let's take other questions in our next video. So do well to watch our next video, the part 3, to better understand how this limit concept works, right? So if you find this class helpful and you want more on calculus, basically from the beginning, I will urge you to join our 200 level channel membership, right? So if you join the 200 level channel membership, you'll have access to all calculus videos from the beginning to the end. So do what to join that level to have access to this particular opportunity for yourself. At the same time, if you're first time here, do what to subscribe to this channel, leave a comment, share this video to your class group and WhatsApp community where you know that other students can benefit from this video. See you guys in the next class. Welcome to Excellent Link Academy.